Hello, I'm Dr Manjir and welcome to Hidden Science. This is the first show of 2014 and we just want to take some time to say thank you so much for all your support for the shows that we've done so far, and the response has been so amazing, so thank you. In the first show of the year, we're exploring the hidden science of water. Has a new state of water been discovered, and can water really communicate information? My guests this week are well qualified to help answer this question. We have Professor Gerald Pollack of Washington University, Dr Mei Wang, who's Director of the Institute of the Sciences Society, and Mark Abadi, who's a holistic psychologist. But first, here's our roving reporter Grace Willis discussing the hidden science of water.
Water. You probably don't give it much thought. Water is one of the most important and abundant substances on our planet. You and I are made up of 70% water, and without water there will be no life as we know it. But what is water? Here are a few interesting facts. Water is composed of 2 hydrogen atoms and 1 oxygen atom. Water is a universal solvent. All major cellular components are dissolved in water. Water can form a large number of intermolecular hydrogen bonds. These factors lead to water's high surface tension and capillary forces. The water molecule is not linear, and the oxygen atom has a higher electronegativity than hydrogen atoms, so water carries a slight negative charge. Water vapour is essentially as invisible as a gas. Water is tasteless, odourless, and its natural colour is slightly blue, although it appears colourless in small quantities. And ice, which is water in its frozen state, also appears colourless. Water, at its maximum density, is 3.98 degrees Celsius. Oddly, it becomes less dense when it is cooled down to its solid form, ice. It expands to occupy 9% greater volume in this solid state, which accounts for the fact that ice floats on top of liquid water. If ice did not float, then the oceans would freeze solid, as the surface would freeze and then drop to the bottom of the ocean, and this would continue until completely frozen. Water also has one of the lowest freezing points. So something as mundane and ordinary as water turns out to be one of the most interesting substances in our universe and sustains all life as we know it. We interact with water every day, so before you take your next sip, take a thought about water and all of its life-giving properties. Back to you guys at the studio.
Thanks, Grace, for that really interesting video. My first guest today is Professor Gerald Pollack. He is Professor of Bioengineering at the University of Washington in the USA. He received his PhD from the University of Pennsylvania in 1968 and has published many scientific papers and award-winning books, including Cells, Gels and the Engines of Life. He's also the founding editor-in-chief of the journal Water. Amongst his many accolades, he is a recipient of the 2012 Prigogine Medal, and in 2013 he published another book, The Fourth Phase of Water. I actually joined Professor Pollack on a Skype call earlier this week, and just in case you're wondering, we apologise for the sound quality on this segment. Okay, so here I am at the People's Voice offices today, and we're talking with Professor Gerald Pollack, who's joining us from Seattle. Hello.
Hi, Manjir. I'm delighted to be with you today, and happy to discuss with you all the interesting aspects of water that we've been studying.
Oh, it's fantastic. I've been looking at your work on the internet for a while. I've read your book. It's absolutely fantastic. So,
thanks so much.
Thank you. Thanks for joining us. And now, to start off with, a lot of people probably are thinking, why water? Because, it's everywhere. So, don't we know everything about it? Hasn't it been studied already?
Many people think that all there is to know about water is already known for precisely that reason. Water it fills our bodies, and it fills the oceans and the rivers and the skies, and the automatic assumption is, well, sure, everything is known. On the other hand, there have been a lot of paradoxes about water. So what's a paradox? Well, paradox is something that doesn't really fit the general understanding, which means something is wrong with the general understanding. And so we've been studying water for the past decade or so, and we found something remarkable. We found that there's a phase or a state of water that's different from what people have thought. So we all learn as school children, we learn that water has a solid state or phase, a liquid, and a vapor. But we found a fourth phase. We found a phase in between a solid and a liquid. And this phase actually is what fills your cells. You think that your cells, or most of us think that our cells, biological cells, are filled with H2O. But it's not so. The evidence is actually that the cells are filled with this fourth phase of water, which is distinctly different from H2O. It's a kind of ordered phase that exists near surfaces. So, for example, if you have a surface like a protein surface inside of a cell, or DNA or such, or a membrane, next to those surfaces, the water molecules will be organized in a certain way. And we've been studying that organization. Some of the properties are remarkable. For example, this phase is not neutral. No, H2O is neutral. We have neutral water, but this phase is charged. It usually has negative charge. And the region of water that lies next to this kind of ordered water or fourth phase, that region is oppositely charged. So it's kind of like a battery. You have the ordered water is negatively charged, and the regular old H2O is positively charged. So it's a battery. And
so if it's a battery, does that mean that we can get it to work things? Can we actually get energy out of this?
Absolutely. The body gets energy all the time from this. Inside your cells is a division of negative and positive charge, and that electrical energy is used to drive many processes inside your body. That's energy that you can tap, you can use, but also you can use it artificially. That is, you can set up a chamber in a laboratory or elsewhere of water next to some surface, and you stick electrodes in the right place, and as long as you have light coming in, see, light is the driver of all this, photons, radiant energy, the light that comes to us all the time. This is the light, this is the fuel that builds up this kind of ordered water and separates the charge. So it's really very simple. You have light input. By light, I mean visible, ultraviolet, infrared, all kinds of radiant energy. That light is input, and it converts the water into this kind of special fourth phase water. We call it EZ water because, well, it's easy to remember, but actually it stands for exclusion zone, because this kind of water, this fourth phase water, just pure liquid crystalline of substance. So we're really excited about this. There's many applications.
I think just to clarify, because it cut out just a bit there. So you've got a surface there, and you've got water, ordinary water, and when you actually shine light on it, what it does is it becomes this fourth phase. So you've got the fourth phase of water is next to the surface, as it were, and it's not just a few molecules, is it? It's actually quite a distinct phase, and that actually ends up with a neutral charge, and then next to that you've got the positive charge of the rest of the substance that's there, and with that you can actually, now does this actually happen spontaneously? So if you were to leave something out, like a beaker of water, and leave it out in the light, does it just spontaneously form this?
Yes, it should do it spontaneously, because there's energy all around us all the time. So we found that the kind of light that's most powerful in building this is infrared light. And if you think about infrared light, well, most of us think, oh, sure, you get infrared light when you turn on the stove or the range. It glows brightly, bright orange, and that's infrared light. But in fact, infrared is being generated all around us all the time. If I'm in a dark room, turn off all the lights, close the shades, and turn on an infrared camera, I see a beautiful image of everything. And the reason I can collect that image is that this light is being released, being generated all the time from chairs, walls, you, me, etc. So it's always there, which means this is free energy, literally free energy that's able to build this fourth phase of water. So because that energy is always around us, you always have this fourth phase of water. And as I said, it's the kind of water that fills our cells.
Wow. So have you actually been able to harness this free energy, and what are the implications of that? I mean, is this something that we can look forward to in the future, that, you know, we can use easy water to maybe power our cars perhaps?
Well, there are talks now, and there's evidence of cars being powered by water. It's not mainstream science, but you can find it all over the internet. It's called Brown's gas, and somehow you put the water in your engine and it runs on water. Now, I'm not an expert on that, but I can say that that water does have potential energy, the energy that comes from the environment. And you can add more if you like. You can direct bright lights or sunshine, if you will, on a chamber containing this water. And indeed, it separates charge. And so there in the future, this remains to be developed. And of course, we're working on it right now to see if we can make it practical. We don't know if it's going to be practical, but we sure think so, because the energy density out of this is really high. It's a matter of practical application, practical techniques to tap this kind of energy. And well, if it works, it could be quite revolutionary. It would be unnecessary to deplete the earth of its valuable resources. It's just water. There's plenty of it.
That's amazing. What have you managed to do so far? Can you actually light a bulb, or with that sort of power, or what sort of things?
Well, it depends on the size of the bulb. We're actually we've actually been working at a micro level using small micro electrodes to discover the properties of very tiny segments of this easy water. But we have plans, of course, to scale it up, and then the amount of energy could be really large. The energy density seems to be, just from a local spot, very high, and so the prospect is quite interesting for the future.
But it's not just the implications for energy that you've got here. There's a lot of you mentioned earlier, the anomalies about water. Everyone's been talking about, why does ice sit on top of, as a solid, sit on top of liquid water when it's a solid? So there's all sorts of sort of things that this can explain. Can you sort of mention maybe a few of them, maybe about the trees, or the fact that ice is slippy? There's all sorts of things.
Okay. Let me start with why ice floats. So I just need a few words to talk about this. What it has to do with the structure of ice and the structure of the fourth phase. Now, we found experimentally that although we all think that we take water and the water freezes into ice, we found this is not true. What happens is, when you reduce the temperature, the water actually converts into fourth phase water. And the fourth phase water then converts into ice. And it's not unreasonable to think that. Of course, we have direct evidence, because we found that the fourth phase water, the structure, is actually very similar to ice. And so this fourth phase water turns out to be, based on the structure and measurements, to be very dense. On the other hand, what happens is, when the fourth phase water is converting into ice, how shall I say, the planes of structure. This fourth phase structure consists of a series of parallel planes. And what happens is that protons engage themselves in between those planes. And it's because you have extra space between the planes, the ice structure then is not very dense. And that's why it floats on the water, because the planes are actually separated by charges, by protons. So now that's the first, and the second has to do with the slipperiness. It was known since Michael Faraday many years ago that on top of ice there's a thin layer of watery kind of substance always. And we found that this water is easy water, because when ice melts you get easy water, and then you go to H2O. It's the reverse of what happens during freezing. So that means during this melt, you have a thin layer of easy water on top. And then on top of that are the positive charges, the protons. And when the ice skate presses on these protons, protons repel one another. And therefore, the ice blade sticks up above the ice, and therefore you have very little friction. It's because it's like maglev. You're right on repulsive protons, and those positively charged protons create the repulsion that gives you almost no friction. So the harder you press, the lower the friction.
So you've got these layers, the hexagonal layers.
Yes.
It's very structured, isn't it? And because you've got the positive charges in between. Thank you very much for joining us today, Jerry. It's been absolutely fascinating. And back to the studio. So that was Professor Pollack earlier this week, who's actually one of the leading researchers in the world on water. So join us after the break when we'll continue exploring the hidden science of water. See you soon. Welcome back to the show. We're exploring the hidden science of water. Is it more mysterious than it might seem? My next guest to help answer this is Dr Mei Wang. She graduated with a PhD in biochemistry from Hong Kong University, and she's currently the director of the Institute of Science and Society, and actually the chief editor and art director of its quarterly publication, which is called Science and Society. She's probably best known for her pioneering work on the physics of organisms and sustainable systems, and has written many books, including, probably very well known, The Rainbow and the Worm and Living Rainbow H2O. She is also the recipient of the Prigogine Medal for 2014. Welcome to the show, Dr Mei Wang.
Thank you very much for having me.
Now, you had quite an interesting insight, didn't you, about water about 20 years ago when looking down a microscope. Can you tell us what happened?
Well, what happened was I have been working with this fruit flies for 15 years. And we decided to look at it under the polarizing light microscope that geologists use to look at crystals.
So what does polarizing mean for people who don't know?
It's actually a special light microscope that if you have crystals, like rock crystals, they will appear as bright colors. Okay. And so I suspected from my work that we should be seeing something interesting there during the early stages of development. But actually, when we went there and looked at the embryos, what we found was just amazing. It was like there was this little larva hatching from the egg, and it was exploring, and it was this little worm, and all I can say is it was carrying a living rainbow inside. It was so beautiful. And I was just completely bowled over, but of course it took us some time to work out what was exactly happening.
So these are the sort of pictures and images you were seeing?
Yes,
there.
These are some of the pictures, and look, these are, it's not unusual because all tiny organisms that you can put under the microscope they look the same. They've got these real rainbow colors. These are just like the colors you see in the rainbow because they're called interference colors.
Right. But you weren't expecting to see this, were you?
Well, I wasn't actually, I was half expecting to see them in the egg, in the early embryo, but not in the adults. And so what was the reason? The reason was that all the molecules in the organism, they were moving so coherently together that at any point, because the light vibrates much faster than the molecules can move, so at any point, if they're moving coherently like that, they are as though seeing this order. And so in order to see the colors, the bright colors, you need this molecular order. And this was the biggest lesson that the worm was telling us, that the whole organism is completely coherent, that all the molecules are coordinated and working together, and not only that, and this is where our main point is, all the water associated with the molecules are also, you know, crystalline and moving together with these molecules.
Because the worm, just like all of us, is mostly water. It's mostly
It's
water
70 to 80% water. And the thing is, you know what? If not for that, life won't exist at all. Now, first of all, I call, you know, this water is what enables all the molecules to work, to transform energy and materials at close to 100% efficiency. If not for that, we would burn out before we could say Christopher Robins or something.
I know when I went to medical school and I looked down a microscope, we were taught to look at the sort of things in the cells, the organelles and all that sort of stuff. We kind of ignore the water. But what you're saying is actually we're putting water back to the central part of life.
Well, water, yes, that's why. Water has always been sort of thought as, oh, boring stuff, you know, it's actually just a solvent. But what it is now is that water is at the center stage of cell biology and medicine and everything, and consciousness, what have you. It's all down to water. And to give you the most mundane example, enzymologists, they still don't know that water is the most important thing. You know, enzymes are what does most of the work in your body, as all biochemists and people know that. Now, but they couldn't work without water at all. They speed up chemical reactions by an order of magnitude up to 23. That means 10 to the power 23. And the reason they can do it is because of water. Water, you know, gives them this flexibility. Well, this is the biggest lesson. Without this kind of flexibility, nothing will work at all.
Mostly we ignore it. Now, you mentioned earlier about all the molecules being coherent.
Yes.
What do you mean by that? And you sometimes talk about quantum jazz as well.
Okay, right. Now, you have to imagine that being coherent is not being uniform. It is that your actions are completely coordinated with each other. It's like dancing. And the best metaphor I can give for it is that all these molecules that are making up cells and tissues and organs, they're dancing together, making music together so coherently that they look as if they are locally free. But because they're so sensitive to each other, that they're keeping in tune and in step with the whole. Does that make sense?
So this is a level of order that we've been ignoring completely.
It is the most, you see, we're used to looking at the world with mechanistic eyes. Now, in the quantum world, it is all different. in the mechanistic world, you can say, well, you know, if you need coherence, then you've got to suppress the freedom for the individual, and then you can have a society. Well, in the quantum world, it's not like that. In the quantum world, it's like quantum jazz, that each player is sensitive to the rest. And it's so sensitive to the rest basically because the water is there to as a messenger for intercommunication. And that it is so sensitive that it is improvising all the time, but it is keeping in tune and in step with all the rest. You know, that is what quantum coherence is. It's a completely dynamic and dynamic wholeness.
Yeah, so it's giving a sort of level that normally we just take a bit here and a bit here.
That's
so
right.
You're saying there's actually a coherent system that goes throughout the whole organism that we've been missing completely, and it's communication through water itself. That's really amazing. Now, how does it actually fit in with what Professor Pollack speaks about with
Now,
easy water?
this is very interesting because water brings us right up to the quantum age. There are people working in quantum physics at the very forefront that show that, in fact, water, a glass of water that you can see just at room temperature is actually already quantum coherent. The reason is that it can interact with the field of the ambient field of electromagnetic waves, and even, you know, like so-called the vacuum field.
Right.
That there is energy in there.
That's the sort of 0-point field people
Exactly,
talk about with the photons popping
well,
in.
what is a 0-point field? The 0-point field is actually the field at like absolute zero, when there shouldn't be any energy at all. And apparently, to their surprise, quantum physicists find that it's actually filled with energy.
That's 0 Kelvin.
Yeah.
Minus 273
Ground,
centigrade, isn't it?
exactly.
Yes, very, very cold when nothing should be moving.
Absolutely.
Physicists have actually found that actually all around us it's actually teeming with activity.
So what happens is that if you take into account the interaction between this field and water, then the water gets excited. And when the water gets excited, it dances between a coherent ground state and an excited state. Yeah. And these then form coherent domains in the water according to the frequency, okay? Now, what happens is that if you have a surface, like any surface, you know, like maybe hydrophilic surface, especially that Gerald Pollack was working on, the water then lines up on it and gets stabilized. So that coherent water, quantum coherent water, is actually stabilized on these surfaces. And that's what I think is he is getting these so-called exclusion zones because these quantum coherent water has very special properties. And one of the properties it has is that because the coherent state of this water is actually very close, like this close, to a state where the electrons of water, you know, that matter is made of electrons and protons and neutrons, okay? So the electrons are outside in the molecules and they tend to come loose. And if they come loose, then there is this very reactive electron. And electron transferred to other molecules, that's the basis of a chemical reaction. Yes. That's the basis of an oxidation reduction chemical reaction that is the basis of life.
Yeah. Oh, wow. So there's a whole new structure of water that's opening up, and it's very, very significant to life, to many, many processes as well. Thank you so much for that. So we have to go for a break now. So join us after the break when we'll be discussing more about the hidden science of water. welcome back to the show. We're discussing the hidden science of water, and with me in the studio is Mark Abadi, who is a holistic psychologist, an international speaker and the author of the book Evolve. Here it is. Mark teaches around the world on a wide range of subjects to do with health and well-being, including the science of energy medicine, and he also recently hosted a global conference on water delivered on Google Hangout. Welcome to the show, Mark.
Thanks, Manjir. It's great to be here.
So why water? What led you to do a whole conference on the science of water?
It's the main thing in life, in existence. You see, everything is duality. Everything is yin and yang. And the Chinese knew this, the Indians knew this, all the holistic scientists from past knew this. Water represents that duality at its most fundamental. You have the oxygen, which is the negatively charged ball, and then you have the two hydrogen ions, which are positively charged. And that dipole nature, two poles, really allows water to perform some magical things. It creates this buffer zone which enables communication to occur. It really is the fundamental nature of communication. Like most things in biology, water was disregarded. Some of my first learnings on this was from James Oschman, who pioneered the understanding of the living matrix, which is the collagen fibers in the body. And the collagen fibers in the body are the connective tissue, also known as. They're the most abundant material in all living matter. So they're the things that go everywhere. And yet again, we find in the collagen that the most important thing for the collagen is water. The person who pioneered the understanding of the matrix of collagen was Albert Sven-Yorgi, who influenced Mae-Wan, I'm so happy to see, and influenced Gerald Pollack. So really, Albert is the...
Wasn't he a Nobel Prize winner?
Yeah, so he won the Nobel Prize for synthesizing vitamin C, ascorbic acid. He actually later said that was a big mistake because he understood that the separation of vitamins into constituent parts actually removes the energetic nature of the environment from which they've taken. So you can take vitamin from an orange and it's totally different to taking vitamin and ascorbic acid separate. The environment is removed. Albert Sven-Yorgi was also the first person to contract a muscle in a petri dish. But the point is, he was a genius. He was fantastic. Towards the end of his career, he started to work with the coherence. He started to work with crystalline matrix. He started to understand that when things join together in a crystalline structure, that these things that we thought were bonded, these electrons, these protons, which by the way is a hydrogen ion. A proton is a hydrogen ion. These things that we thought were bonded and were sealed and were solid in this kind of Newtonian billiard ball concept, they became loose, they became fluid, they became belonging to the entire system rather than one location on it. They diffused over the entire system. Mae-Wan.
Actually, it would be useful to see what Saint-Georges actually found out. He was the first to propose that water at the interfaces is excited water. And it is because of this excited water that photosynthesis, for example, could work at all. Because if not for that, if the water isn't already excited, you would need X-rays in order to make to free the electrons. Because it's already excited, so you can use red light and maybe a bit of blue light, and that's enough, you know.
So he really is a pioneer. And does that sort of go on to the work of Gerald Pollack as well?
So yeah, it does connect with Jerry's work very much because...
that's the water at the interface,
So it's almost like the matrix, the crystalline matrix. What Jim identified... you know, I mean, Jim was across the hall from James Oschman. Sorry, I call him Jim. He likes to be called Jim. I call him Jimbo. But what James Oschman discovered, I mean, he worked a lot with Albert Sven-Yorgi because he was across the hall from him in Maine. And what James started to identify is that the collagen, because one of the things that Sven-Yorgi said is that collagen, proteins, are semiconductors. Now, semiconductors are the most important thing to life and to everything. Semiconductors are why we've got computers, why we've got cameras. We need them. Conduction is when you have free electrons in a material. The electrons are kind of fluid and free, and they'll just sort of go anywhere. They're like, sort of, you know. put themselves about. An insulator is where the electrons are bonded tight so they won't move. A semiconductor can behave as both. And it can behave as a store of information and an emitter of information. It's a very beautiful arrangement. It is the yin and the yang together, if you like. Both the bonded and the expressor together. Yeah. So what Sven-Jorgi said is that the proteins were semiconductors, or actually conductors.
So the collagen proteins.
Collagen for one.
To water?
No, well, this is it. I think that we should bring it back to water because it is actually the water aligned by the collagen.
Yeah, so we were getting there.
Yes,
we were getting there.
So
scientists tried to disprove this.
Yes.
They took the collagen out and they did what they normally do, which is
always
remove
look
the
at
environment, and then they look at it and they dried it out and they tried to pass a current through it, and lo and behold, it didn't pass a current. And they wanted to bring Sven-Jorgi down. They were like, old man, he's out of his time. But actually, it was because they dehydrated it. They removed the water, which was the fundamental nature, as Mae-Wan says. It's the water that enables the communication to occur. It's the water that enables the flow of electrons, probably through the exclusion zone at the forefront of collagen, because collagen is a hydrophilic substance like DNA. Hydrophilic means water-loving, as opposed to hydrophobic, which is water-hating. And so the entire body is hydrophilic. So the entire body is water-loving, and as such, it attracts water to it. And it does what Jerry describes as his exclusion zone experiments. It self-orders itself around biological hydrophilic substances, which is DNA, collagen, myosin, actin. All the parts of the body are surrounded by a coherent structure of water.
So really we're looking at a whole new way of seeing biology, where we've got hydrophilic surfaces in our body, proteins and all sorts of different molecules. Yes. And next to that we've got, as Jerry's talking about, the fourth state of water.
Yes.
And all of that means, which is the electrons that are freely moving and maybe even creating that polarization next to that, which could open up all sorts of new understandings about the whole state, which is really, really fascinating. Now, James Oshman also talks about the fact that water is the communication system of the body, and it even communicates with the quantum vacuum. What do you think about that?
Well, you know what? Jim doesn't limit it to the water, because actually, as I started with this, everything's yin and yang. Water and collagen, you have electrons and you have protons. And a new flow of information understanding is proticity, which is the flow of protons, flow of hydrogen ions. What it seems to be the case, and this is one of the things that James Oshman presents, is that the collagen surrounded by the water, inside the water you have the flow of hydrogen ions, perhaps just outside the exclusion zone, in the, where Jerry shows is that there's an excess amount of hydrogen. I was just speaking to Jerry last night about the possibility that actually the flow of hydrogen ions just outside the exclusion zone is probably more intense at the very point just outside the exclusion zone.
Explain that again. You've got the hydrophilic surface,
so
you've got the exclusion zone, and then you've got the
So
protons.
what happens is the water self-orders.
Yeah.
You've got the hydrophilic surface, collagen, DNA, whatever.
Hydrophilic means water-loving.
Water-loving, nephion. And then you've got this exclusion zone, which basically is high in electrons because it's excluded everything. And when you put a pH dye, which a pH dye tells you how many hydrogen ions are in the water, basically. Yeah. It color codes it, so you can see that the most intense level of hydrogen ions are just outside the exclusion zone. So it kind of peters off away from the surface. So you've got the exclusion zone, which is like a buffer zone. For me, the exclusion zone actually is like a buffer zone between two warring factions. The warring factions of the hydrogen ions, but they're not warring, they're actually in a quantum coherent dance. They're actually dancing together. But of course, if the hydrogen ions were just next to, if there wasn't an exclusion zone, the hydrogen ions in the water would just bond with the electrons in the collagen, and there would just be a reaction. Right. There needs to be a buffer zone. So the electrons in the exclusion zone offer a buffer zone between potentially, this is where we're on the edge now, between the flowing hydrogen ions through the water, the organized water, and the flowing electrons through the piezoelectric nature of collagen. Collagen, remember, is a conductor. We found that out after I'll explain that in a minute. So collagen, remember, is a conductor. That means it conducts electrons. And we know that it's a conductor when it's wet, when it's hydrated. So this is just a kind of, we're going on to almost a theoretical basis of what is the meaning of these things. Piezoelectricity is something that is a nature of a semiconductor that is spiral, that's helical, and a semiconductor means that it's piezoelectric. Piezo, pressure, electric, electric, pressure, electric. That means if you press something, it emits an electron.
Sort of one of the mechanisms of how like EMF pollution and things like that can actually manifest its effects, because that's something that...
Well, I mean, you know, one of the things with piezoelectric is that if you press it, it emits an electrical signal, electromagnetic. If you put an electromagnetic signal in, it changes its vibration. So it is a decoder of information. Now, you're emitting an electrical field, an electromagnetic field. Traditional scientists would say, yes, but it peters off to about here and we can't even detect it, so how can the body? The body is the most miraculous quantum device we've ever even come across. We're so nowhere near to understanding the delicacies of it, the subtle nature. And if you experience, you know, even if you go into yourself and you experience meditation, then you find the subtle nature of it. For me, the best scientists are the ones who meditate, because they understand that there's a subtle nature of holism behind what they split to understand.
So really our cell phones could be resonating with all of this quantum coherent water and structures in our body and causing all sorts of effects and all sorts of things as well, not just cell phones, Wi-Fi, that sort of thing. So we're going to have to go to a break now. So join us again after the break for more on the hidden science of water. Welcome back to the show. We're discussing the hidden science of water. And, you know, a lot of people think when they hear about the hidden science of water, they'll think of someone called Dr Masaru Emoto in Japan. And he did a lot of work on looking at the structures of water when you put some intentions on them, and the work was very popular. What's your opinion on Emoto's work?
Well, it's very interesting because I was lucky enough to have visited his lab in his absence, because he was in the UK while I was in Japan, and so he very kindly said to his people, "Show me anything she wanted to see," and I was very impressed. And what he did was that he took water from different places. At first, how he started tap water and then spring water and polluted water, clean water. And he showed that when you put a drop on a petri dish and then put them in the freezer, what happens is that this drop, if you put it in a plastic petri dish, it doesn't actually spread out. And then very soon, a crystal, like a flower, comes out at the top. And he would do a sample of 50. And then you can see that, looking at these 50 samples, they were all the same and yet they were all different. So this is how he actually does his experiments. And I have absolutely a lot of respect for how he does it. And then what you're saying is that there are these very controversial aspects, which says that your intention can actually, you know, interact with the water. If you say love, music as well. Music is fine, because music, you've got waves, and you can actually, you know, you can influence it, the crystallization process. By the way, the beauty of the crystallization is that each is unique. So he started out by looking at snowflakes, which is unique.
Yeah.
And so all the very controversial aspect, it raises the question of, is it possible that our consciousness can communicate with water? Now, if you ask me, I would say, yes, it is possible.
What about you, Mark? I mean, this is really
there's no doubt that consciousness communicates with water. There's no doubt about that. Emoto's work, very pretty. My problem is with the replicability of it.
Right.
Very few people have been able to replicate his work,
and
that's always
unique.
No, because they didn't actually do it in exactly the way he did.
So you know, I mean, look, we all know about the Benveniste controversy when they all went.
Some people listening might not.
Jack Benveniste was a wonderful pioneer in the electromagnetic recording of information in water. So he did what homeopaths do.
Well, he was a very orthodox scientist.
A very orthodox scientist in France, in Paris.
Yeah.
So what he did, what homeopaths do, was basically he took a substance and he diluted it down until, probabilistically, there was not one single atom remaining inside the water. Then he diluted it some more. And what he found is that substance, that material, behaved as if it still had the material in. Now, for me, it behaves in the same way homeopaths work. It leaves an echo, almost like an imprint, like a jelly mold. You know, if you've got the spaceship of the jelly mold of a spaceship, it's the actual spaceship there. But the mold itself is not the spaceship, it's the inverted spaceship. So for me, homeopathics are diluting out the actual thing and almost diluting it until it becomes the inverted thing, and then you take it in and it absorbs. That's why you treat like with like. It absorbs the actual spaceship that's in your body.
Is there evidence for this?
No, that's my complete theory.
Okay.
That's my complete theory.
I think we are at the cusp of understanding it. And the key to it is the coherent domains that form in the water. Like, I was trying to show you this. So in this glass of water, because it interacts with the light, with the electromagnetic fields outside, there are these tiny coherent domains, and which also emit electromagnetic signals. And there is now evidence from cell biology, even though people don't recognize it, that molecules intercommunicate by specific electromagnetic signals. And molecules that tend to work together are attracted by the same frequencies. And so if you can imagine these little domains of coherent water emitting these signals, then they could attract the interacting molecules onto the surfaces.
But isn't the real trouble with his work is that it's like distant intention, you know, just putting like a word onto a glass and then freezing it.
Well,
and
you see,
that's a problem. I mean, can our consciousness really affect the system?
We emit fields all the time. We are both field and particle.
But it's not even just normal physics fields, it's quantum entanglement. I mean, entanglement is one of the most fundamental physics experiments they show, and it was what Einstein, Rosen and Podolsky actually theorized, you know, before they had the ability to do it. It is basically something's resonating, they're together. You take these two ions apart, charged particles, they're still vibrating opposite to each other, they're still rotating opposite to each other. If you change the movement of one, instantly the other changes. Now, Lynn was famous for Lynn McTaggart was famous for pulling all the information together, and she referred to a lot of other good people who measured the speed of that, and again, Geissin and Aspect,
Alan Aspect,
and Alan and Geissin. They measured it, and I think they came out with a value of 26,000 times the speed of light. This communication occurs.
It's instantaneous, no matter
It's probably
how
instant,
far
but
apart
Einstein said nothing can travel faster than the speed of light. He didn't exactly. He said nothing can accelerate to faster than the speed of light. He didn't actually mention anything that was already moving faster than the speed of light, or that was already entangled.
Well, a lot of physicists accept that about the non-locality. We've done the experiments. What they don't accept is that consciousness has got anything to do with it. That's the nub, isn't it?
Yeah. Well, how can it not? I mean, as above, so below. You talk about water, you talk about the yin and the yang. We have here a representation of a yin and yang. We are water sat here. I'm the oxygen, you're the hydrogens.
And there is nothing mysterious about it, because, you know, our fields actually can be measured outside us.
Yes.
Yeah.
And people have done experiments where they separated two people, they can't see each other, and they can they show that if they have some kind of sympathetic resonance, you know, that their brain waves become coherent.
The skeptics hate this sort of work, unfortunately.
Well,
but,
you see, I think that it needs a lot more, it invites a lot more experimentation. And I have no time for people who dismiss it out of hand, who don't want even to do any more experiments. Because to me, the most exciting thing is that it's opened up this complete field And now we can go forward, you see, because...
Let me make a suggestion as
Yeah.
to why the traditional scientists hate it. And your viewers are going to love this because it's controversial.
Okay, just before we go, I just want to get something to do with water as well that people
Sure.
can take forward. What do you recommend for people's health as well? I mean, if with this coherent system of water, should we be drinking a certain type of water? Should we put intentions on our water?
You have to be very, very careful about what you drink. There are already experiments done by Professor Koruga in Serbia, who found that people who drank bad water in one city, as opposed to people who drank, ordinary good water in another.
Is that clean water? Or?
Yeah.
Yeah.
But there's also the quality of water. We can go into it.
Coherence.
But what they found was then they analyzed their skin, and they showed that the degree of hydration was completely different. The people who drank bad water, their hydration level decreased, and as you know, that's the first sign of aging.
You've got to watch the water
Yes.
that you drink. What about
Yes.
yourself?
You know,
What do you
health-
recommend?
Nothing is anything without everything else. Nothing is anything without everything else. Psychologically, you ask what people can do. There's a reason why every single culture on the planet blesses their food and drink. Because you bring consciousness to it, you bring a focus of your electromagnetic intent, a focus of gratitude and love and heart and presence to your water will make your water quantumly coherent more than if you're not. Just like the Emotos. That's the Emoto stuff.
Emoto is always saying we must give thanks.
Yeah, so we give thanks.
And can that protect against harmful EMFs as well, maybe? Would it make you
Definitely. The
stronger?
quantum coherence, the more quantum coherent your body is, the more likely it is to offer this buffer zone, this exclusion zone buffer zone, that will absorb electromagnetics and not be disturbed.
These are just now hypotheses,
Yes.
okay?
Yeah.
But because don't take our word
it
for it.
seems to be that we need to do another show on this. There's so much to talk about. So thank you both for joining us today. It's been mind-blowing. It really
Absolute
has.
pleasure.
Thank you for joining us on Hidden Science today, and join us again next time because we're going to have some more science from the cutting edge. Goodbye.